Hey everyone, happy Monday. Hope you had a nice weekend. Okay, so today we're going to take a little throwback to what we did on Friday, circumference and area of circles. So here's our do now. If the circumference of the circle is 23.8 feet, what is the area? So we're looking for area, but we're told that the circumference is 23.8 feet. So I'm going to start by writing down my circumference formula. Circumference equals pi times diameter, cherry pie delicious. I'll substitute in 23.8 for our circumference. And now we'll solve for diameter. So divide both sides by pi. Got to grab our calculator, 23.8 divide by pi, and we get a big long decimal. We're told round to the nearest tenth. That's our final answer. So here, to be more exact, I'm going to leave it to the hundredths place, which is going to be 7.58 for now. We want to find area, which is pi r squared. So we need the radius. So we're going to take that diameter, divide by 2. So let's do that. 7.58 divided by 2 is 3.79. Now we're ready to substitute into our area formula. Area equals pi times 3.79 squared. We'll do our squaring first, 3.79 squared. And again, I'm going to round to the nearest hundredths place, which would be 14.36 pi. There's our answer in terms of pi. Wish I did that, but we're rounding to the nearest tenth, so we've got to multiply. 14.36 times pi, and now finally we can round to the nearest tenth, which would be 45.1 feet squared. So last week for 2 days we talked about area and circumference of our circle. Today we're going to bring that out to polygons, right, our many-sided closed figures, and talk about area and perimeter of our polygons. So we want to go to page 21 in our booklet and just take a look at our formula sheet. Now this formula sheet, we've got circles, we've got squares, we've got rectangles, we've got parallelogram, we've got triangle, we've got trapezoid. The only ones here you have to memorize, and sort of also just kind of like in life you should know, well, I think circle, but I'll give that to you on a quiz or a test, but you got to know square and rectangle. That's expected. If you look to the rectangle formula for me, please, perimeter, that's an L. That's an L. That's an L. It's not a 1. That's one of my least favorite math questions, is when people go, Miss Dasso, why is there a 21 there? It's not a 21. It's 2 times the length. Context, people. Length and width. Okay? So we're going to take a moment. We're going to look at where do our formulas come from, specifically for triangle and trapezoid, and we're going to base that off of our formula for a parallelogram. Base times height, and where does that come from? It comes from our rectangle formula, our length and width. Okay, so you might want a piece of paper, take a couple notes, and we'll go to that now. Let's take a look at a couple of our area formulas. So our rectangle, right, we all know and love, length times width. Doesn't matter which one we call length, which one we call width, just that they are perpendicular, meaning that they are forming a 90-degree angle. Okay? And really, that's the basis of where our parallelogram formula comes from. Area equals base times height. We know our base. Our height is how tall it is. Important fact to remember is that base and height are perpendicular. That's our perpendicular symbol, meaning they have a 90-degree angle. So let's take a look at why does this formula work? Well, if you look at our parallelogram, if you notice, it's kind of got like a triangle on this end. If we take a scissor and we cut that triangle and then slide it over to our other edge, what we actually form is a rectangle, and then we can see our length times width. So parallelogram, base times height. On to our triangle. Area formula for a triangle, we can either say it's 1/2 base times height or base times height divided by 2. And that also comes from either our parallelogram or our rectangle. So if we look here, I've got a rectangle. I can see our base, our height, they're perpendicular, forming that 90-degree angle, just like I said. Well, where does the triangle come in? Well, if you take that rectangle, grab a scissor, and let's see how good I can cut today. Cut it in half. Now you've got a triangle, which is half your area of your rectangle or your parallelogram. So again, just an important fact, even in the triangle, base times height are perpendicular. Now, some of you might be saying, well, Ms. Dasso, that looks perfectly fine for a right triangle, but does that work for a non-right triangle? Well, you know what? It does. It does work for a non-right triangle. So here's our non-right triangle. To me, it looks like it might be a little bit obtuse. We still have our base and height. It just looks a little different than our previous triangle. Our height is drawn here with that dotted line. We're shown that it's perpendicular to our base, okay? Base doesn't necessarily have to be on the bottom. It's just going to be perpendicular to the height. So how does that relate to our parallelogram formula? Well, if we take that triangle and duplicate it, whoop, whoop, movie magic, and rotate it and position it, boom, now we've got a parallelogram. Base times height. So our triangle, which was half our parallelogram, is half its area. Half the base times the height. Last but not least, we have our trapezoid. Okay, so our trapezoid kind of looks like that Pizza Hut sign, Pizza Hut symbol. Our area formula is 1/2 the sum of the base 1 plus base 2 times the height, or you can think of it as base 1 plus base 2 times the height divided by 2, whatever your preference is. When we look at our trapezoid, we have our height. It's perpendicular to our base. We've got base 1, base 2. It doesn't matter which one you call base 1 or base 2. It's just a little subscript of the number 1 and number 2. So again, this formula is also based off our formula of a parallelogram. How, you might ask? Well, a little movie magic again. If we take that trapezoid and we duplicate it, and we take it and we rotate it and slide it into place, then all of a sudden, again, we have another parallelogram that's been created. Now with this parallelogram, yes, we have our base 1. When we duplicate our trapezoid and put it here, now we have a base 2 right there in green, and on the top, a base 1 in blue. So if we look at our base of our parallelogram, it is the sum of base 1 and base 2 times our height, and our trapezoid is only actually half of that, so the times 1/2 or the divide by 2. Okay, so now let's take these formulas, let's put them into practice in our booklet on page 22. Okay guys, on page 22, we're taking a look at triangle ABC, and we're going to find the area and perimeter of triangle ABC. One update to our diagram we need to make, if we look here, here's these dotted lines. Those dotted lines are not actually a part of our triangle, so C should not be labeled there. It should in fact be labeled here, where it's actually a part of the diagram. So please do me a favor, move that over, okay? So as we go and we find our area, we know area of our triangle is 1/2 base times our height. So we want to first identify our base and our height. The base and the height are going to be perpendicular. So I'm kind of eyeing in on this 90-degree angle here. So our height is going to be 1.4. That's our height. Now the question here really is, what's the base? We know it's perpendicular for it. Is the base 1 meter? No, that's not actually a part of the triangle. That's just showing us the distance from that angle C to where the height is dropped to show that it's vertical, okay? Our base is actually here, the 3 meters. And that tends to be one of the hardest things students have trouble with, is finding the base and the height in the triangle. Okay, so height 1.4, the base is 3 meters. Okay, 1.7 is not the height because it's not perpendicular to the base. So let's substitute in. Our area is 1/2, base is 3, height is 1.4. When I go to use my calculator, instead of doing the fraction 1/2, I'm just going to do its decimal, 0.5. So I'm going to do 0.5 times 3 times 1.4. We weren't given any rounding direction, so I'm just going to leave it as is, which is 2.1, and we're doing meters squared, so our area 2.1 meters squared. Okay, Now, as we find the perimeter of any shape is the distance around the shape itself. So that's going to be from A to B, B to C, and C to A there, like I just showed us in our diagram. We're not including that height 1.4. It's not a physical part of the sides of our triangle or that 1 meter there. So our perimeter, really all I'm going to show is just adding up the sides. We don't need to write down a formula there for the triangle. Okay, so we've got, let's see, what's that? 5.6 plus 3, that should be 8.6. So 8.6 meters. Perimeter is a linear unit. Okay. Now as we go to number 2, you'll notice there's no diagram. We're just going to work with our formula. A trapezoid has an area of 88 centimeters and its bases are 7 centimeters and 4 centimeters. What is the height of the trapezoid? So notice we're given the area here. So this is almost like how in our do now we had to start with circumference and then calculate the area, kind of solve for an unknown there. So we're told the area of the trapezoid. I'm going to write down the formula. 1/2 times base 1 plus base 2 times our height. Now let's substitute in our information. We know the area, so I put 88 in for A. 1/2. We know our two bases, 7 and 4. It doesn't matter which one you put for base 1, which one you put for base 2. And then our height. Our height is the unknown. That's what we're going to have to solve for. Now, order of operations, we go to parentheses. I'm going to add 7 and 4. So we get 1/2 times 11 times h. 88 equals 1/2 times 11 is 5.5. So 88 equals 5.5 h. Let's divide both sides by 5.5. And we get that our height is equal to 16. So the height is 16 centimeters. Okay, so as you go on to do your classwork on page 23 and 24, on page 23, if you're having trouble seeing a diagram, go look at that PDF version of the booklet and adjust your diagram as you need to. Okay, so have at it. Let me know if you have any questions. Feel free to email me, ask a question on the Edpuzzle. You can post a question on the Padlet also. Make sure you're going back and you are checking your Edpuzzle for comments on your questions, and you're checking your Padlet for feedback on the work you posted. Have a great day, guys. Thought I'd finish the day with a little math joke for mathy folks. Today's math joke is, what do you call 3 feet of trash? A junkyard.